Okay, in this section 2-7, we're looking at proving segment relationships. And so we're continuing on with proofs. Now in the last section we looked at algebraic proofs, and we started with those because they're something that you're a little more familiar with. But in this section we're going to start incorporating some geometry into our proofs. Okay, the format is the same though. You have a series of statements and reasons, and you're given a piece of information, and through those statements and reasons you have to arrive at what you're being asked to prove. Now, before we start, let's take a look at our given information. BC equals to DC. So they're saying that these two pieces are the same length. All right? They're saying these two pieces are the same length. And what we're trying to prove is that AB, this piece, plus DE, this piece, equals to AC, this whole thing. Now, it makes sense that that should be true because by segment addition postulate, we know that AB plus BC equals to AC. So if these two are the same, then this piece plus this piece should also equal to AC. All right? So we know that it should be true, but we've got to prove it. So first steps should never be an issue in the proof. The first step is always writing down the given information. BC is equal to DE. Those two segments are the same. And we know that because it is given information. All right? So the first step in a proof should never be a problem for anyone. You're just writing the given information. Now, your next step is to see if there's anything else you can get out of the given information. In this case, the answer is no. And so what we want to try to do now is see what we need for our prove statement to get what they're asking me to prove. Now, here's the deal. Okay, I can never prove AB plus DE equals to AC unless I get an AB and an AC in my proof. Okay, so right now I have a DE in my proof, but I have no AB and no AC. So my next task needs to be to try to get those two things into my proof. Because like I say, I can never prove this statement without an AB and an AC. So I need to try to get those in my proof somehow. It turns out that there's an easy way to do it on the very next step. Earlier we mentioned segment addition postulate. So if I use the segment addition postulate with segment AC, AC is equal to AB plus BC. So I'm just going to write that equation, and that'll give me the two things that I need in my proof. So AB plus AB plus BC equals to AC. And how do we know that is a true equation? By the segment addition postulate, and we can abbreviate that. Segment addition postulate. Remember, in proofs, which are a line of deductive reasoning, you can use, remember what we said a couple of sections ago when we give possible reasons for deductive reasoning, any laws, theorems, postulates, definitions, formulas, facts, all those kind of things can be used. So segment addition postulate definitely can be used to justify a statement in a proof. All right, now, I'm pretty close to what they asked me to prove. The only thing I need is I need BC to become DE somehow. So if there's a way that I could magically change BC to DE and get what I want, that would be great. Well, it turns out, well, what is BC equal to? DE. So when you take something out and put what it's equal to in its place, that's substitution. So AB plus, so instead of BC, I'm going to take that out and I'm going to put DE in its place, equals to AC, and now I have what I was asked to prove. And how do we know we could do that? Well, when I take something out and put what it's equal to in its place, that's called substitution. Okay, and now we are done. Okay, let's try another one. We have some given information. Let's just take a look at it. Q is the midpoint of PR, so I know these two segments are the same. And R is the midpoint of QS, so if this has 1 mark, this should also be 1 mark. So technically all three of those pieces should be the same length. We want to prove that PR is equal to QS. Okay, so let's start with the given information as usual, which is Q is a midpoint of segment PR. And also R is the midpoint of QS. And that's given information. All right. Now, the next thing that we want to do is you want to see if there's anything else you can get out of the given information, and in this case, the answer is yes. Well, if Q is the midpoint of PR, then we know that PQ has got to be equal to QR. If Q is the midpoint of PR, then PQ's got to be equal to QR. And likewise, if R is the midpoint of QS, then we know that QR is going to be equal to RS. Okay? And that's by the definition of midpoint. By the definition of midpoint, we know those two equations arise. All right? So we can get that out of the given information. And so now there's something else we can get out of this. If PQ equals QR and QR equals to RS, then I know that PQ equals to RS. And remember, that's the transitive property. Transitive property, right? So if A equals B and B equals C, then A equals C. That's the transitive property that we just used. Okay? Step number 4. Now we need to start thinking about, because that's pretty much all we can get from the given information. Now we want to see how we can get PR, right, equal to QS. Now once again, just like in the last one, I don't even have a PR in here anywhere or a QS in here anywhere. So my next step is to try to get those things into my proof. Well, how can I get a PR into my proof? Well, if I look at PR, remember a good way to get parts that you need with segments into the proof is with the segment addition postulate. And so if I look at PR, I know PR is equal to PQ plus QR. So that's going to be my next step. PQ plus QR equals to PR. And that's by the segment addition postulate. All right. So why did that help me? Because now at least I have a PR in my proof. Okay, so the next thing that I want to try to do here is I want to try to get a QS into my proof, and I can do it the same way. Well, QS is equal to QR plus RS. So QR plus RS equals to QS. And once again, that's by the segment addition postulate. Okay? Segment addition postulate. So now I got a QS in there. Now my task becomes, okay, I've got PR and QS in here. Now I just need to get them in the same equation somehow. Okay, so there's got to be some kind of a way that I can get PR and QS, okay, into the same equation. PR and QS into the same equation. All right, so we got to kind of think about how this can work just a little bit. All right, so let's focus with this statement right here. So QR plus RS equals to QS. All right, now look at this part of it. QR and RS. QR and RS. So if I'm looking at these two now, right, if I'm looking at this RS statement right here, I know from here that RS, right, is equal to PQ. RS is equal to PQ, right? So if I can take this RS and turn it into a PQ, well, remember, PQ plus QR is equal to PR. And then I can get PR and equal to QS into the same equation. So this is almost like a puzzle that you're trying to put together. So again, if I can take from step 3 RS out and put PQ in its place, look at the step above. QR plus PQ is equal to PR, and then that'll allow me to finish it. So let's do it one step at a time. So RS is coming out, and I'm going to put PQ in its place. So this will be QR plus, so instead of RS, I'm going to write PQ equals to QS. Now, once again, I know this is substitution. So in this equation, I took RS out and put what it's equal to in its place, PQ. Now, how did that help me? Remember, I'm trying to get QS equal to PR. And so look at QR plus PQ in step 4. Well, what's that equal to? It's equal to PR. So I'm going to take this part out now and put what it's equal to in its place, which is PR. And on the other side, that's equal to QS. And I know that from substitution. And guess what? That's what they had asked me to prove. And so now we are finished. All right? So a lot of times this is like trying to put a puzzle together. All right, let's go to the next one. All right, so what are we given? AB is congruent to DE. So AB is congruent to DE. So we know these two segments are the same. And BC is congruent to EF. So we know these two segments are the same. Based on that, we want to prove that AC, this whole segment, is congruent to DF, this whole segment. All right, so we have some given information, so we can write that down. AB, segment AB, is congruent to segment DE. All right, so that's the first thing. And we also have the other part. BC is congruent to EF. All right, and that's given information. All right, now, anytime you start with congruent, you want to change those statements to equals. And the reason why is because you can't do addition, subtraction, multiplication on objects. Remember, congruent is for objects. But you can do addition and multiplication and division and subtraction on numbers. So I'm going to change these from congruent to equal. So if segment AB is congruent to segment DE, then that means the length of AB is equal to DE, and the length of BC is equal to EF. So what did I do? I just changed these from congruent to equal. And I can do that by the definition of congruence. All right, I can do it by the definition of congruence. Okay? All right, so now, let's see, what else can we get here? All right, so I've got AB, DE, BC, EF. Remember, I'm trying to get AC equals to DF. So let's see if we can get an AC in here. Well, AC is equal to AB plus BC equals to AC. Once again, segment addition postulate. Okay, and likewise, let me use the same thing to get a DF in here. Well, DF is equal to DE plus EF equals to DF. Again, segment addition postulate. Okay, and so that's allowed me to get these two things into my proof. So now I need to try to get them into the same equation once again. All right, so let's see if there's any kind of a way that we can try to get those into the same equation. All right, so let's do this. DE equals to AB and EF equals to BC. So I'm going to go ahead and substitute those two back in. So I got AB plus BC equals to DF. Thank you, sir. And so again, I can do that by substitution. Now, remember, I'm trying to get AC equal to AF, or to DF, but look, what does AB plus BC equal to in step 3? Equals to AC. So I'm going to take this out, put AC in its place, and so now I've got AC equals to DF, again by substitution. Okay. Now, we're not quite to what they asked me to prove, because this says that AC is equal to DF, but I was asked to prove that segment AC is congruent to segment DF, so we have to switch it back at the end from equal back to congruence. So I'm going to switch it to segment AC is congruent to segment DF. Okay? And again, that's by definition of congruence. Okay? By definition of congruence. And so now we have gotten back to what they asked me to prove. So anytime you go back and forth from equal to congruent or vice versa, you're using the definition of congruence. And you know, doing these proofs is really kind of like putting a puzzle together. You're trying to put all the puzzle pieces where they should be. And again, just like the last one, I'm not going to ask you to do a full proof from start to finish by yourself, but there are blanks that you will have to fill in. So that will make it a little bit easier. All right?